Good morning, everybody. We'll be starting here in just about a minute or so. I just wanted to welcome everybody and thank everybody for taking time out of their busy days to sit through this webinar. We will be starting it just about another 20-30 seconds or so. Just give everybody a few more minutes to jump on. Another well-received webinar. This is, I think, our fourth in a series of year-long webinars and probably continuing past that, but we've been getting great attendance each time. So once again, we want to thank everybody for joining us. This webinar will be recorded, as you can see. We will use this to provide additional training and review online, so you'll be able to go to our website and be able to review this if you want to at a later date. So I guess we'll get started. We have a 45-minute webinar, and we will try to get through the webinar in time to have some questions and answers at the end. So this is about bike detection. I am Matt Zinn. I'm the Application Sales and Technical Services Manager here at Eberly Design, but also work with Reno A&E. And this, by the way, is a Reno A&E product. Through this webinar, we will talk about safety for bicyclists. We'll also talk about the loop detection technology that we provide for bicyclists. Also, we're going to talk a little bit about a new concept that we have, which is the inductive loop system. So not only do we provide loop detection at the processor side, but we also provide the loop wire, and the ground installation is for a better system. We'll also talk about the proper materials to use for installation. And later, we will have a question and answers the last 5 minutes or so. But if you do have a question, please write it in the panel, the control panel on your screen. There's a section called questions. Just go ahead and write it in there. It'll pop up on my screen, and I will try to answer them as we go. If not, we'll get them all at the end. And if you are interested in TARP points, we'll be providing TARP points for this presentation. It is about an hour long, so we'll be giving 4 TARP points. So let's get started. First of all, we'll talk a little bit about a history of bike safety. The first bicycle was invented in 1817, and the first vehicle was driving around the streets about 1892 or so. But the very first accident with an automobile was against a bike. At least that's what I found is in recorded history on traffic safety facts. And in 2007, another study suggested that 700 bicyclists die annually, with over 44,000 bike and car accidents occurring each year. This is the reason bike safety is so important. Even though 700 bicyclists die, that sounds like a small number. That's still a huge number. And if you add in the fact that there's about 45,000 bike and car accidents every year, that's a huge number, and we need to find a way to reduce that. So if you look at the accident breakdowns, you'll see that a lot of accidents happen just because things happen. But if you look at the items in red, those all happen to be where a bicyclist or pedal cyclist could happen to be at an intersection. So we broke those out, and it looks to be about 44% of most accidents with bicyclists happen at an intersection or near an intersection. So if we can reduce that number by providing better safety at the intersection, we'll greatly reduce that number of 700 fatalities a year. The bicycle safety support groups and advocate groups are really focused on trying to provide better safety for bicyclists. They're putting on webinars and actually seminars and all kinds of things lately. I've been attending quite a few of them, but really the focus is on education and public awareness programs. It is also about changing behavior of the bicyclists to obey traffic laws. They do great education in that realm. We need to do a better job as well in providing the information about how we can detect bicycles better, and are attempting to provide that for them on an ongoing basis. In the most part, bicyclists have been kind of a non-existent entity. We've always had timing for vehicles, we've always had timing for pedestrians, but we've had very little input for a bicyclist. They'd either have to wait for a car to pull up, or they'd have to go push the push button. So we need to provide better detection for them, and that's what this is all about. Also, MUTCD is making some changes reflecting bicyclists by providing new outlines for signal heads and signage specifically for bicyclists. So again, that's just another way we're going to be able to provide bikes more safety at the intersections. So currently, designated bike lanes are probably the biggest safety feature that have been going on. Still, a lot of manual bike push buttons are still out there, and if they're not at the street, obviously the bicyclist has to get on the sidewalk to push the button. We're going to talk about how we help designated timing and controllers, because most of the new controllers now do have bike timing parameters in them. So now you can provide specific timing for bicyclists to give them a little bit more time to get across the street, and we'll talk about that and a reason why we do that in a couple slides here. But for the most part, all the new technologies out there, loops, video, microwave, are all providing some type of bike detection. And we believe that the loop detection is really one of the more sophisticated and yet accurate types of detection out there. So throughout this presentation, I do have a couple polls I'd like to ask you. And this is simply just a way to find out some information about our viewers here. So let's start off and start one poll here. And if you can, just go ahead and answer the question there. And it'll take just a couple seconds to fill out, but just click on one of the buttons and that you have on your screen, and we'll do this for about 20 seconds and then just move on. All right, looks like we got a good percentage of you voting, and I appreciate that. Okay, we'll continue on. All right, the whole reason for this whole process and doing bike detection is pretty much because of AB 1581. AB 1581 is a California law, Assembly Bill 1581, that was passed in 2009. It basically said that all new intersections in California must have detection at all approaches that will detect a bicycle. And any intersection that is 50% or more upgraded, it will also have to require that every approach be able to detect bikes. So this is what really started everything off. And if you can see at the bottom, the last three were the approved current technologies that could be used for bike detection. So Reno, well, let's talk about why we want to do the bike detection first. Bike detection is really about a couple things. First of all, it makes the intersection more efficient. We don't want to give more time to a bike than's necessary, and the only way we can do that right now is if they push the push button, they get pedestrian times, and pedestrian times is actually way too much time. We also want to make sure that the bike riders have enough time to get across the street, so you don't want to use vehicle times. And all of this different timings, the three different parameters, the vehicle and the bike and the pedestrian, all ensure that we use the timing at the intersection most efficiently. So if you imagine a pedestrian takes X amount of seconds to cross the street, a bike can do it just a little bit faster than that. And obviously a vehicle will go much faster. So when you put all those three at an intersection, obviously we have to have different times for each of the modes of transportation that we're talking about. So what is the timing that we have to give a bicyclist? Well, since Caltrans came up with the law, they also came up with a guideline for the time, and really it is, if you add up the green, the yellow, and red, it has to be greater than 6 seconds plus whatever the width of the intersection is plus 6 feet, all of that divided by 14.7 feet per second. And whatever that number is, that is the time you need to provide for a bicyclist. All right, another quick question here for you. Again, just to find out a little bit more about our audience, please answer the question, and this will take another 20 seconds or so. And after this question, we'll start talking about our system, what Reno and A&E has developed for a detection system. Our next presentation coming up, by the way, next month will be on the ATCC cabinet. We did this webinar about 3 months ago, and we will be doing it again next month. So if you're interested, you can sign up for that one as well. All right, looks like we've got about most of them done. So we'll close that one out. All right, our next slide is about the first half of the system. Again, we're talking about an inductive loop system now. We do not talk about loop detectors without having to talk about the loops themselves. So we're starting this whole process off with the bike detector because it is really an integral part of the detection itself using the loop wire that we use. But from going forward, we really will talk about loop detection systems. So when Reno A&E decided to get a bike detector out there, we wanted to go a step further than just detecting a bike. We wanted to be able to discriminate between bikes and other vehicles. So this whole process was able to determine that we could discriminate against cars, but we also found that we could discriminate against motorcycles, scooters, mopeds, and every other small vehicle out there, motorized vehicle, because bikes create a signature that we can recognize, and when we recognize the signature, we can determine very easily that it's a bicycle, not anything else, and we will show some slides here in a little bit that prove that out. We also provide the outputs for vehicles and bikes on separate channels. So if you did want to use the detector, the loop detector, as a vehicle detector, you're more than welcome to use it as a vehicle detector, and it will detect cars and bikes and scooters and everything else, but we will output the bikes on a separate channel. We can also count bicycles, and we can output those so that you'll have an ability to use those bike counts in your traffic planning. So the basic functionality of our C1100 and C1201 detectors is that it's a 2-channel detector, but we have the 4 outputs. So with 2 loops, we can detect vehicles and bicycles, and those are the 4 outputs. Bike detection comes out on the channels 3 and 4. We also have the bike timing that relies on field green inputs. So we do have a secondary device that goes into the cabinets, in those cabinets that don't have the green sense on the back plane of the detector rack. So it's a simple installation, but we do require the greens to be able to provide the bike timing. The bike timing basically allows us to provide bike timing in those controllers that do not have bike timing parameters, the older TS1 and older TS2 controllers that didn't have that developed in them. So you don't have to change out the controller to get your bike timing. and it does require a very specific loop design. As you can see here in this drawing, we have two loops. The first loop, the round loop, is actually what you could consider an existing loop. So if you have an existing stop bar loop, a 6x6 or a 6-foot round circle, you could use that loop to detect the bike, and we'll do very well in detecting the bike and continue to do that, but it doesn't differentiate with an existing loop. If you want to do differentiation, you have to use the other loop that's in the drawing there, which is at the 45-degree angle. It can either be a rectangle or it can be a parallelogram, depending on which lane you put it in, but it does have to be 45 degrees, and it has to be a leading edge, trailing edge of 42 inches or 3.5 feet. We detect the bikes by putting the loop across the whole lane, and that is one of the benefits of this. We don't have any blind spots there. If you use an existing 6x6 loop, there is some margin on either side of the lane lines that bikes like to ride in that we may not detect a bike, only for the fact that the bike does have to be on the loop. So when we install our bike differentiation loops, we put it across the whole lane. Again, it's installed at a 45-degree angle, and our leading edge to trailing edge is again 42 inches or 3.5 feet. So time for another poll here real quick. If you could please tell me which type of video detection you use, and this is basically the primary type of detection. I'm sure a lot of people have a lot of different mixes of detection technologies, but just curious on what type of technology you prefer. All right, it looks like everybody's getting to answering that question. Looks like right now it's pretty close between inductive loops and video at about 26 and 29% each. We do have a lot of people that online today that are not with an agency, so that takes a big chunk of it. But give you a couple of seconds to finish that up. All right, we'll move on. So installing and setting up this technology is not rocket surgery, somewhere between rocket science and brain surgery. You just basically install the loop. It's a prefabricated loop, so it's very easy to install. You configure a couple detection settings and you really just walk away. Very little maintenance. Actually, there is no maintenance. If you install the loop correctly, it will last a lifetime. And our loops are very solid loops, so we expect them to last for the lifetime of the roadway. One of the things you do have to install again is the ability to get the green inputs into our device. We call that a phase green input module, or PGI. In a TS1 cabinet, it's really not required. TS1 cabinets actually had the field green inputs on the back of the detector rack. In TS2, that went away. So we needed to do that in TS2. We also need to do that in 332 cabinets. It's very simple. You just wire the field greens to the bottom, and it inputs into the detector card through a simple phone cord type of connection. And each phase green input module can handle up to 2 detector cards. So it's pretty easy to install. It also has the ability to have some outputs. So if you can see at the top, we can have a pulse output for each of the cards that it's attached to. And this allows you to turn on a relay or do something with it. If you want to turn on a sign that says bikes present or whatever you'd like to do, you can do that. And it's pretty simple to do. So once this is installed, then all the detector cards will have the bike timing capabilities. So how does it detect a bike? This is a patented technology. This is we hold a patent on detector analysis for the signature that we provide or pick up. And as you can see, the vehicle on the left creates a huge change of inductance compared to the bicycle on the right, which is a very small change of inductance. And you'll also notice that the bike creates a triple peaked change of inductance, where the car only produces the one spike. And that is the signature that we're looking for to provide bike detection. If you see scooter is completely different. It's still very small, but it has a different signature. We look at a motorcycle, again, still relatively small compared to the vehicle, but again, not the same signature. So this is really how we detect a bike. There's also the question, well, how do you detect a bike if there is a car on the loop? Well, it's pretty simple. If you can see that the car, while it's on the loop, has the spike coming down, but while it's sitting on the loop, the inductance comes up a little bit, but as the bike rides over that, we will see that triple peak, and again, recognize that as a bike and give the bike timing even though there's a car on the loop. Where this comes in real handy and is prevalent is having the loop between a left turn and the adjacent through lane. Where bikes like to ride up to make their left turn, we would normally have a car sitting on that loop, and as the bike rides up, we'll also detect that. So will it pick up, again, will it pick up the bike in a normal presence loop? Yes, it will. We can do that, but again, you can see that if you imagine that is a lane across the whole width, there is the margins on either side where we will not be as able to pick up the bike as we would if the loop goes across the whole lane. So other examples, we do have this ability to use it as two types of loops. One where we only detect bicycles and one where we detect bicycles and cars. So where we would only want to detect bikes is in a bike lane. We would want to ignore any car that happens to go into the bike lane. And also, as I suggested, between the left turn and adjacent through lane, that we only want to detect bikes because we don't know where the vehicle may lay if it crosses the loop, whether it's in the left turn or in the through lane. In all the other lanes, though, we would use it as a dual purpose loop or dual mode type of detection, so we can pick up the bikes and we can pick up the cars. Again, just some instances of how we do some of the technology. Again, it will pick up a car both in the presence loop and if you use a standard loop, it works just well. It just as well as any other loop that we can detect on. The second part of this whole system is the most important part. And again, that is one of the concentrations that we are doing this year on our technology, is to make sure that it is a system that you're buying and not just a loop detector. Just as you wouldn't buy a video detection system without the right video camera or a radar system without the right radar, we don't think that you should buy a loop detector without the right loop installed. And most contractors are very good about how they install their loops and do a very good job, but you could get wire that is not the proper wire installed and it could cause a problem. There's also training that requires loops be spliced a specific way. And in this system, since we are looking for such small changes of inductance, splices can become a detriment to the system. So in our systems, we would prefer not to have any splices at all. But unfortunately, that usually isn't the case. So if you're going to splice and splice either in a handhold or somewhere else, there is a technique that can be used that does a very good job. And again, that is all about the training, which we would be happy to provide any of contractors or cities in the ability to install these loops properly. So one more question here. This will be the last one, I promise. Just go ahead and answer these ones and tell me which one of these is true. All right, looks like so far most people have answered the question. All right, so this is kind of a trick question, but I'll go ahead and close that out and move on. I've just been told nobody's been able to see my screen. I apologize for that. I thought I was showing the right screen, but I guess it was just a top screen. But if you're interested, I can go back through it real quick and go do the slides. But right now, we'll just continue this on, and I will provide those slides again if you want to review them on our website later. But the poll basically asked, does wire have to be big? No. With today's technology, the wire does not have to be big. Do the loops have to detect ferrous metals? No. That would require us to be a magnetic type of detection. We don't have to detect metals. We detect anything that is conductive. So copper, aluminum alloys, titanium, anything that conducts electricity, we can detect. Again, the loops wire have to be big? No. With the technology in our manufacturing, we are using actually 22 gauge wire, which is much smaller than commonly used in loop detection today. And that's because our insulation is so strong, it becomes the strength of the wire. Instead of having to pull 12 and 16 gauge wire, we're actually pulling which gave the strength in the conductor. We actually pull a smaller gauge wire with the insulation being the strength in the pull. And this always comes up to the question, well, what about a carbon fiber bike? Can you detect a carbon fiber bike? Yes, we can. Actually, with a caveat, we actually detect the rims of the carbon fiber bike if they are aluminum or titanium. There are those 1 in 10,000 bikes out there that might have a full carbon fiber rim. And for those, we would have to say we know that we can't detect those. But for all the other bikes, which we believe are well in the 99% range, we can detect all those bikes. The last myth is loops fail. Well, loops, if they're installed correctly, will never fail. It's the road that fails. Construction happens. Somebody might hit your home run with a backhoe or some kind of saw. If the loops are not installed correctly, there could be some water leakage, but if they're done correctly, and again, we'd be happy to do training, loops can last 20 years very easily. So we use a prefabricated loop, and this loop is actually manufactured in our facility in Reno. It is made out of a material called cross-linked polyethylene. It is really built to last. It's very easy to install. It is actually adjustable, so you don't have to have a template that you have to put on the ground and saw cut through the template to make sure it fits properly. We do have some adjustment capabilities. It's made for any installation, so you don't really necessarily have to have this set up for a bike detector. It could be used as a 6-foot round if you want that technology. It can be made into a 6x60 quadrupole if you have one that big, or a 6x30 rectangle loop. Whatever size of loop, we can manufacture these loops to specification. It does use, again, the new technology of cross-linked polyethylene, and in the long run, it really saves money because you can reduce your maintenance, which is really no maintenance, and it does give you, it takes less time to install and less time to repair because you're just dropping the loop into a saw cut. You don't have to wind it, you don't have to splice it. It's already has the home run on it. You just pull it all the way back to the home run. The reason we do a prefabricated loop is because all the wires are in one insulator. So all 4 turns of the loop are in the same insulator. So these wires never move between each other or in comparison to each other. They don't vibrate against each other, and they don't stretch and shrink against each other. This is important because all that creates noise, and that noise could hide the small signatures that we're looking for bikes. So this loop has to be extremely solid and not create any noise, and this is how we ensure that. We also, since we make it in our facility, we do some testing on it before we send it out. We make it to 1,000 megohms, and if it passes that, then we ship it. If it does not pass 999 megohms, we will fail the loop and start over. A lot of people who install their own loops, even some of the standards out there I've seen as low as 20 megs, would be okay. We definitely would fail at 20 megs. So again, the quality of the loop that you're getting and the fact that we do the testing ensures that this loop is completely done right. We also put it in a saltwater bath for 3 days before we do the testing. So if there is any intrusion of water anywhere in the loop, we'll catch that and again fail that loop. Because we do the testing, we also warranty these loops for 10 years. So we provide an ability to get it repaired if there's any material problems with that loop other than the road failing. We provide 2 types of loops. We provide one loop that is used for saw cut installations, and we use a 1/4-inch saw cut. Standard saws that are out there installing loops today, we use the same saw. We also provide an underlay method, which is milling and new installations. So if you want to put it below the roadbed, it works just fine. 3 inches is usually the saw cut installation, but you can put it deeper than that if you want to. 4 or 5 inches is not a problem. We will still detect the bikes just fine, but that will get you under a milling, so the next time the road is milled, you wouldn't have to replace that loop. When ordering these loops, it's pretty easy to do. You tell us what size of parameter the loop is and whether it's a quadrupole or not, and then how long the home run would be, and we can provide that loop in any size. That way you don't have to splice it. And again, we add a little extra footage around the perimeter in order to provide the adjustability. So the way we do the adjusting is that we actually have our own little splice box, because we do come from a 2-wire lead-in to a 4-turn loop. We do have to splice that, but we provide that in a splice tube, which is where we splice the wires. And what we do is we solder each wire and then put a heat shrink around each of the wires, and then we encase it in this tubing with a water-phobic material that provides the ability to keep the water out of that tube. And wherever that tube lays on the home run is where you would drill a 1-inch hole, and that 1-inch hole you drop the tube down into, and at that point it takes up the slack of the loop and fills up the space. So again, pretty easy to do. And here you can see one of our contractors in California that has been doing a lot of installations doing that. And you can see in the bottom left corner of the picture the corner of the loop, and that's where all the loop wires come through. And then the slack is what you see coming out of the saw cut, and where that splice box ended up on the home run cable is where he drills the hole, and he'll drill that down all the way to the bottom of the drill bit, and that's about an 18-inch drill bit. And then he just drops the splice box down in there and takes the rest of the home run all the way back to the cabinet. So pretty easy installation, and again, that takes up all the slack and allows you to be a little bit off on your loop cutting and not have to worry about it. So Again, the advantages of doing the prefabricated loop is it's constructed in a controlled environment. We don't need to worry about splicing or waterproofing. The loops are tested. Again, it is a salt water bath for 3 days and then megged at 1,000 megohms. The cross-linked polyethylene is a standard polyethylene that has been irradiated, and that irradiation allows the molecules to become much more bonded to each other, and it becomes a strong, not only insulator, but it also becomes strong enough to be able to pull and use that as the wire, as the strength of the pull. It doesn't stretch, and it allows for the prefabricated loop to withstand a little bit more pavement shifting without ripping and tearing and coming apart, which is one of the problems with poor roadway installations in materials that tend to rut and groove. So it does a better job there. Again, it won't withstand a lot, but it does do a better job. And because we do all this in the technology we use, we warranty everything against failure for manufacturer defects for 10 years. So the other method, again, is to put it under a milling or in a new road surface. And you can see here that we are putting this under a milling. And in each corner of the loop, there is a little metal bracket, and that little metal bracket is just tacked down either with a nail or a nail gun, and it's put in place. And this is actually a 6x6 square loop that you see here, detection for system detector, but it can be used the same way as a bike detector or any other type of detection. And once it's nailed down, then you can drive the track right over it. This is a thicker wire than the one that's used for the saw cut, and it provides an extra layer of insulation so that you can actually run the pavement track right over it and lay the asphalt right down onto the loop without having to provide any extra coating. You can see these people here added a little asphalt down just to keep it from moving around once the track went over it, but it's really not that necessary. You can do that just on the corners, and that would be enough, or just on the sides. So once you've installed it, you can drive the track over it, and when you're finished, you get a pretty roadway with no saw cuts. And one thing that I should mention with the saw cuts, we don't cut the corners, the 45s out, or recommend cutting the 45s out like normal loops you've seen, only for the fact that the cross-linked polyethylene can go around a very sharp turn without cracking or causing water intrusion through those cracks. So all you do is you take the same 1-inch drill that you use for drilling out the hole for the splice box, and you just tap out the corners, and that's all that's necessary. So again, that saves some time in the saw cutting process itself. I watched a loop crew in California do a very good job of installing 8 bike loops, and they did that on and off the street within about 4 hours, and that was 4 approaches, 2 loops per approach. So again, it does not take a lot of time, but it can happen with right loop crews very fast. That is the end of the presentation. I'm going to see here if there's any questions that need to be answered. Looks like there are a couple questions here. And let's start off. The first question was, can we get TARP points? Yes, you can. Again, this is the page that has the TARP points. So if you send me your information, first and last name, IMSA certification number, phone number, your address, your email address, agency or company you work for, and the city in which you work, that's the information that IMSA needs. Especially if you don't have your certificate number, they can find it out with all the other information, but please provide all that information to me. You can send it to the email at the bottom of mzinn@editraffic.com. The second question was, yeah, a lot of people weren't seeing the screen presentation. I will have, again, the PowerPoint up on our website. It'll be on the Reno A&E website, and I'll have that up as soon as I can get it up there, and you'll be able to see the slides. I'll also try to work it into this recording so that I can sync up the slides with the words and provide a video of the presentation as well. So I apologize again for not having the right screen shared. I thought I had it, but I'm still kind of learning these webinar stuff. So other than that, that was most of the questions. We have one here. Do you think Reno will be thinking of wireless road detection anytime in the near future? At this time, that has not been a discussion, but who knows? Technology always grows, and we can always look at other ways to do it. Another question is, what is your view on the use of piezoelectric sensors? Well, piezoelectric has always been a technology that's used in red light enforcement because it is very accurate, it is very sensitive, and it does a great job. It's also very expensive to install. So it's a technology we can, that has its uses. I don't see us using it for bike detection. I think this bike detector does a great job. We have done some studies in California and in Oregon where the detection has been proven in the high 90s so far. And one of the studies that's being done in California right now that has not had the information released yet is actually doing a side-by-side study between video, microwave loops, and actually two video companies. And when that information is provided, we will provide that report. But it looks again like our technology is surpassing with the initial studies being done. So again, piezo, great technology, but I think we've got a great technology too with these loops. Another question is, what is the best configuration for bicycle lane detection? Again, the best configuration for the bike lane detection is the 45-degree parallelogram, because you need to get it as close to the curb as possible, and the parallelogram allows you to do that. It does need to extend about 1 foot out into the adjacent vehicle lane. That way we can guarantee that even if a bike is riding on the bike lane, which some bicyclists like to do, we can provide detection throughout the lane. It does have to be 42 inches leading edge to trailing edge. So again, that's 3.5 feet. But that's pretty much it. We do need to have it back at least 1 bike length away from the stop bar. We do have to have the bicycle ride all the way through the lane to get the signature. So it can't be right at the stop bar. Just a little ways back is fine. You can put it 100 feet back if you want to, but it does have to be far enough back that we have a bike ride all the way through it. And that was from Randy Ensel. Well, that takes up about our 45 minutes. I appreciate everybody's time. Is there any last questions? Here's another one. The Model C 1201B counts bicycles and keeps the counts. Would the count be logged in the TS2 traffic controller? It can be. So if you designate a separate input into your controller, you could count all day long. We also have the ability to count out the PGI, the phase green input, and you could use that to have a separate input into the controller. It's a pulse, 24-volt pulse. So again, that's just a detector input, just like an open collector. So you could have that input into your controller as well and use that as a counting device to count with. So yes, you can be logged in the TS2 controller very easily if you separate the inputs. So that's the best way to count. And that is from Brian Antilla. So again, 45 minutes is up. I apologize again for not being able to see the first half of the slides. They will be up on the Reno website by the end of the week. Again, if you want IMSA TARP points, please send that information to me, and I'll be happy to get that to you. Once again, we want to thank everybody for attending, taking time out. Again, my name is Matt Zinn. We'll be doing the next month's presentation on the ATCC components. That's the Advanced Traffic Controller Cabinet components. And that'll be the second Tuesday of June, which happens to be June 9th. Once again, thanks everybody. Have a great day and enjoy the rest of your week.